Hey physics class, how's it going? We got our new week here talking about conservation of momentum as well as kind of 2D momentum. So when things either collide at different actual directions or if something breaks apart and goes into different directions, how can we kind of look at that? So let's look at the first part of conservation of momentum. Basically, what does this mean? This means that if two things collide or if two things are interconnected beforehand, whatever the momentum of that is has to be exactly the same as what happens after. So if two things collide, if me and Mr. Lang run into each other, okay, we both have momentum, that same net momentum has to be the same as the net momentum afterwards. Okay, let's say also I am riding a bike. If suddenly I jump off the bike, my net momentum of me and the bike, as well as me jumping off the bike, net momentum has to be exactly the same. Okay, or a skateboard. A skateboard's a really, really good example. If I'm on a skateboard, not that I've done a lot of skateboarding, but if I'm on a skateboard and I suddenly jump off either backwards or forwards, that skateboard is going to do something different because of, again, the changing momentum. Our momentum beforehand has to be the same as the net momentum afterwards, okay? And so let's kind of give a few scenarios of, I'm not going to put any numbers, but I'm just going to take a few scenarios looking at our formula. So if you were in the lab last week, you would have seen this formula. Okay, it's long. It's going to be in the formula sheet, obviously, for this week. But it says M1V1 initial plus M2V2 initial. So basically, momentum of object 1 initially and momentum of object 2 initially equals M1V1 final and M2V2 final. So the momentum of object 1 final and then momentum of object 2 final. Okay? And so let's go just through a couple examples here where we can look at what's going to end up happening. So let's say that two different objects collide and their velocity becomes 0. So let's say two people hit each other and they collide and they end up having a velocity at the end of 0. Okay? So if both velocities end up of 0, that means my net momentum at the end would be 0, which means these two need to cancel out. Whatever momentum 1 is, momentum 2 has to be the opposite, okay, which means kind of like negative. And how do you get a negative momentum? Well, it's always going to come down to velocity, okay? You can't have a negative mass, okay? I can't be negative 5 kilograms. That's not exactly how it works, okay? So that means the velocity has to be in a different direction. If I'm going east, they're going west, okay? And those momentums have to cancel out. So anytime two things hit each other and they both become 0, that means these two in the start have to cancel out. Let's say if I have, and this is an example that we would have done last week. Let's say you know the momentum of this one. So let's say this one's 10 and this one is 5. So we have a net momentum of 15. If you know that this one is 7, you can already kind of figure out what this momentum is. And then knowing that momentum, you can figure out what the velocity is, okay? Because 15 minus 7 will mean that this is 8. It has a momentum of 8, and then whatever the velocity is depends on its mass, okay? What if we do this? What if I have a momentum of 5, momentum of 10, momentum of 5, and then this one has a momentum of 19. And then you're like, well, Mr. Westwood, that's not possible. If I have momentum of 10 and 5, I have 15, I can't get 19 here. Well, I could. That just means this needs to be negative. And again, what does a negative momentum look like? I can't have a negative mass. It just means that something has to be going the opposite direction. Here is an example, okay? If, I'm going to use me and Mr. Lang for some reason again, it's just easier right now. If me and Mr. Lang are both running the same direction down a hallway, okay, and if he pushes me as hard as he can forward, I fly forward with a lot of momentum. But if he actually goes backwards after pushing me, because he pushed so hard on me, he actually went backwards a little, well, now he has a negative momentum because he is going the opposite direction. And so, yes, I can get a bigger momentum here than these two together. It just means this one has to be going the opposite direction now, okay? And that's kind of similar to if an object were to hit, if they were both moving this way, but one were to hit, and then this one goes backwards, again, we can have that happen where we get a negative momentum. Okay? But this formula will help you out kind of figure out, again, that before momentum and that after momentum. All right. Let's kind of talk about 2D momentum, okay? This is going to come back to a lot of vectors. So we haven't done vectors in a little while, but if you go back, and we're going to look at two kind of types of vectors. One, combining vectors, as well as our change in a vector, okay, our change in a vector. Because here's two scenarios I want to kind of give to you. Here's one, let's get rid of this for now. Let's say there is a car, okay, driving this way, and there is a car driving this way, okay? Whatever the momentum they have, let's say this momentum is 100, and this momentum is 50. Okay, we can figure out the momentum beforehand. We have that. And either they're going to bounce off each other or they're going to stick together. Okay? And so first off, these are going to act just like vectors. Okay? This is going to move off in this direction. Okay? And to get that, again, there's two parts of this. Getting the magnitude in the sense of, like, how do I know what the velocity is or the momentum is? That's going to be our a squared plus b squared equals c squared. And then how do I get the angle? Again, that is inverse tan of y over x. Y being our north and south directions, our x being our east and west directions. So that's the first way to kind of combine these to figure out what the new momentum and new actual angle is. Okay? Now, one little side piece here. If these two stick together, it's not too bad to like figure out the momentum. Like you'd get this to actually get momentum. And if you want to figure out the new velocity, just make sure that you're going momentum divided by mass total. And don't worry, I'll talk about this and I'll give an example of where this would happen. But because these two things would stick together, their masses would kind of add up. Okay? So this is one example of how we'd be using our vectors again, where here's one car hitting the other car, and we have to do our a squared plus b squared equals c squared to get this. Here's another example, though, where let's say we had, and this is going to be exactly from a question that's on your sheet in the sense of 2D momentum. Question 1 talks about a ball that is thrown this way, and then after, it doesn't tell you what happened, it says after it is hit, okay, like this. Okay? And so let's say it is 41 and 53. I might as well use the same numbers that's on the question. How do I figure out what the change in momentum was? Okay? When I have the change in momentum or the change of vector, I don't want our vectors to look like this. I want our vectors to look like this. So here's our starting point, and the change in vector was this, 53 at a certain angle. I can't remember, I think it was 30. Don't quote me on that right now, but I'm pretty sure it's 30. I need to find the change in a vector, which would be this. Okay? And again, how I'm going to get that resulting vector, how do I get that change in vector? I have an x here. I need to break this into an x and a y. And then when I have that x and y, the nice thing is I'm going to have a y value here. I'm going to have a new x, which I can add to this one because it's going in a different direction. If it was going in the same direction, I may subtract it. But because it's going in the opposite direction, I'm going to add those x values because that was my change. If it was going this way first and then moving the other way, I had a big change in my actual x component. Okay? Once you have that new x component and you have the y component, you can go back and do your a squared plus b squared again. Okay? So if you want a little touch-up on vectors, because it's going to be, your vector is going to be important for our 2D momentum. If you want to go back to some of the videos that I had under, I can't remember, it was under one of our intro weeks, but it was basically the videos were called adding vectors together, as well as then changing vectors, or I think it was maybe called advanced vectors, okay? And that'll be kind of some of the stuff that we're going to use for our 2D momentum. All right, so there's a little intro, conservation momentum, as well as our 2D momentum of what we're going to do this week. I have 3 more videos coming up. Basically, the first one's going to look at simple conservation momentum. Number 2 is going to look at a little more at the advanced start of the conservation. And then video 3 is going to look at just our 2D momentum, where we have all this changing angles and that kind of stuff. So hopefully it goes all well. Thanks so much, class. Talk to you soon.